Hey, what's up guys? Nick White here. I do tech and coding stuff on Twitch and YouTube. Today we're going to be doing a tree problem called Deepest Leave Sums. Medium problem. It's actually a newer one, got added recently. And it's actually not, it's pretty easy for a medium problem compared to, there's an easy one, like path sum tree or something that's much harder and it's easy. Given a binary tree is just a tree where each node has 0, 1, or 2 nodes. So this has, 0, this one has 0, you could see. You could have 2, you could have 1 child, just 0, 1, or 2, because binary is base 2 number system, right? Return the sum of the values of the deepest leaves. By the way, I have a green screen, so I'm not blocking the code anymore. Just had to, say that. I just got it. Okay. Given a binary tree, return the sum of values of its deepest leaves. So deepest leaves in this case, what I thought it was at first was, okay, this is a deepest leaf, this is a deepest leaf, and this is a deepest leaf. It's just talking about the leaves at the very last level. So even if it's like a leaf node down here, that doesn't count. It's just the very, very final level of leaves. So to do this, it's actually not too difficult. What we're just going to do is a basic BFS, or level order traversal, where we just go this level, this level, this level, and we just have a sum of all the nodes at each level. So 1, 5, whatever this is, 9 plus 6, 15, and then at this level, we don't care about the sums of these, so we'll reset it every time as we loop. And then just in this level, we'll just calculate, we'll have the sum, and then just return the last sum that we get, because it's the sum of the final level. So we just want the final level of nodes, the sum of the level at the final. It's pretty straightforward, just a BFS. So we could use a queue to do this. That's how BFS is, normally done. You just set up a queue. So we'll do a queue of tree nodes. This is how all BFSs are. You just do new linked list, right? And then you just, oops, what did we do wrong? Queue. Seems good to me. Why is it indenting weird? That was weird. What am I doing? Okay. Queue of tree nodes. Sorry about that. Kind of ruined the flow of the tutorial, but it's fine. Okay, so basic BFS is, this is how basic BFS is. You have a queue, and you just put the root on, right? So the first thing on the queue is this. And then we evaluate them in levels, right? So we're going to evaluate the nodes as levels. So we're just going to evaluate this. Then we're going to put, the children onto the queue. So 2 and 3 will be on the queue. Then we evaluate all of those. Then we put all of these on the queue as we evaluate. And we just add these to a sum. And you just keep doing it. It's just level by level. It's, basic as it gets. So we're just going to make a level sum variable. So we could actually just do that down here. Level sum, we'll keep track of the sum of all the nodes at each level. We'll just set it to 0. While queue is not empty, so as we go through, we'll be adding things to the queue, so it won't be empty until we get to the very end and evaluate the last nodes, because there will be no more nodes to put onto the queue. We will have a loop in here, and we're going to go from 0 up to size, I++, and size is going to be queue.size, the size of the queue. And basically this just works so that we evaluate all the nodes level by level. You need this loop because, we put 2 nodes on the queue. We can't just evaluate 1 node at a time because we won't be able to keep track of the level. So you have to do it level by going up to the size, because the size of the queue will increase each time. So the size will be 1, then it'll be 2, then it'll be 3. Then it'll be, it'll be different every time. So we want to go up to the size of that level, basically. The queue size will be the size of the level, how many nodes are on at the current level, right? Okay, so when we go up to the size, all we're doing is, you do tree node, current node equals queue.pull. Sorry. Queue.pull. So you pop a node off the queue. So you pop 1 off the queue. 1 is on the queue. We pop it off right away. Okay, now we evaluate it. We add it to the level sum. So we say level sum plus equals current node.val. Now we have to add the children onto the queue to go over the next level. Okay, so to go over the next level, we don't want to add nulls onto the queue. Like we don't want to add 7's children are null, 5's children are null. So we want to do current node.left we want to do a check that the node dot the children are, you know, not null before we add it to the queue. Then we do queue dot offer, and we do current node dot left because left isn't null. And then we'll just copy and paste so we could speed this up since I messed up earlier. This is for the right node. Make sure the right node isn't null, and then you could add the right node, right child onto the queue. Wow, okay. Pretty straightforward, right? Okay, so we pop nodes off, and we evaluate the whole level. We get the level sum, right? And basically all we're going to do is just every time we go to a new level, we just reset the level sum back to 0. So level sum goes back to 0. And yeah, and then when you get out, you'll have evaluated. So it'll be like, okay, yeah, we'll just walk through it in a second. You return the last level sum, basically. Because level sum gets set to 0 right at the beginning of the loop, right? So level sum 0, level sum 0. Okay, root is on the queue, so 1's on the queue. Okay, we evaluate that level. 1, we add 1 to the level sum. We add 2 and 3 onto the queue, right? They're not null, so we add 2 and 3 onto the queue. Okay, next, level sum is 0 again, so new level sum. Now we evaluate 2 and 3 because we go up to the size of the queue because it's 2. So we go 2 and 3. We pop those off. Okay, 2 plus 3 is 5. So we get level sum is 5. We add all of their children nodes onto the queue. 4, 5, and 6, right? We reset level sum back to 0. We add 4, 5, and 6. We get 15. Then we go back to 0. Then we have 7 and 8 are the final ones on the queue. We evaluate both of those 15. And we break out of the loop because the queue is empty at this point because they don't have children nodes to add. So the level sum doesn't get set back to 0, and then you return it. That's basically it. I did this live on live stream. I got the green screen, so you know, please like and subscribe to help me grow the channel. I'm taking it a lot seriously because my setup is I bought a new PC for the streaming. I got the mic, I got the green screen, I got everything. So please like and subscribe. Help me support the channel. I really appreciate everyone that watches, supports the channel. Peace. I got another message today saying someone got into Google again because of my videos, which is really awesome. So thank you guys for watching. Please, everything. Thank you. And yeah, I'll see you in the next video. More questions coming. All right. Peace.